once again, imagine you have two vectors, an 8 Newton force and a 10 Newton force acting 60 degrees apart at a common point. The next step in the graphical method involves creating a coordinate axis and redrawing these vectors on that axis. So you have those two vectors now redrawn on the axis 60 degrees apart with a positive y, positive x, negative y, and negative x. You then split these two vectors into the y-axis and the x-axis. So looking first at the y component, for this 8 Newton force on the y component, you'd say 8 times cosine of 60 to bring it onto the y axis. Because it's on the negative side of the y, we shall say negative 8 cos of 60. We then look at the second force, and it's already entirely on the y axis, therefore we just say plus negative 10. This totals up to negative 14 newtons. We then look at the x component, and again looking at this force, that remaining angle is 30 degrees, therefore the x component of this force is 8 times cosine of 30. It's on the positive side, therefore it's positive 8 cos 30. And on the second force, because it's completely on the y-axis, it is simply 0. Alternatively, you could say 10 times cosine of 90, which will still give you 0. And this totals up to positive 6.9 newtons. Looking at these two forces, effectively, you could redraw them like that, with 14 newtons in the negative y direction and 6.9 newtons in the positive x direction. And this will be the resulting force of that entire triangle. From Pythagoras, r squared is equal to 14 squared plus 6.9 squared. Therefore, R is equal to 15.6 newtons. Once again, because it's a vector, we must have a magnitude and we must have a direction. If we took that angle there as our angle x, x will equal to the arctan of 6.9 over 14. Therefore, angle x is 26 degrees. So we can therefore conclude that we have a resulting force of 15.6 newtons at an angle of 26 degrees to, initially this line follows the y-axis, therefore it corresponds to that line. So therefore we can say to the 10 Newton force. Just to go through the steps again, you create two axes, positive y and the positive x. You redraw your initial vector along those two axes, and then you resolve each force in the y component, and then again each force in the x component. And looking at these two vectors of the two components, you can resolve them using Pythagoras theory, and then work out an angle for either side of the triangle, and then you have a direction as well. You need magnitude and direction for a vector.